On November 24th, ThreeI Atlast no longer appears as a block of drifting ice but as a system quietly choosing its own path. In NASA, images at last look smooth and stable, while in amateur images at last trembles slightly, tilts slightly like a restless source of light. On paper, Atlast is still called an interstellar comet, a time capsule, but the fine-tuned orbit, unusual metallic composition, forward-facing light, and the match with Jupiter's Hill radius are gently pushing the research community toward the hypothesis of technology and autonomous AI. In quiet control rooms, NASA and scientific teams use AI itself to filter data hunt for strange signals and simulate millions of scenarios around Atlast, while the series of radio signals every 19 hours, the metal-like reflective surface, and the subtle orbital adjustments make Atlast look more like a machine following its own checklist than a natural comet. And the real fear, therefore, is no longer a violent impact but a much softer possibility. ThreeI Atlast is merely choosing for itself a perfect observation position, scattering a few small probes, then quietly watching the Earth for a very long time after it has disappeared from our region of light. Right after this, we will explore the latest discovery of Dr. Avi Loeb, who argues that ThreeI Atlast is an extraterrestrial intelligence with geometric abnormalities that cannot exist. The first time the official images appeared, they looked almost comforting, as if space had finally decided to behave. Placed beside the raw frames from backyard telescopes, ThreeI Atlast seemed to be living two different lives. In the NASA release, Atlas sat centered and composed a neat core wrapped in a quiet, symmetrical haze. In the amateur pictures, Atlast wandered slightly, its light smudged and restless coma tilted and brightness breathing from night to night. One version of ThreeI Atlast has every rough edge averaged away, every fluctuation softened into a single trustworthy frame. The other version lets Atlast flicker and drift, exposing the minor asymmetries that standard processing quietly sands down. That mismatch is small in pixel space but large in meaning because Atlast already strains the models built for ordinary comets. Between those two renderings hangs a quiet question whether we are removing noise or erasing behaviour when we tidy Atlast into a press-ready portrait. In the late hours, that gap between polished and raw becomes the place where ThreeI Atlast feels most mysterious. In those faint discrepancies, the true story of Atlast may be hiding, waiting for someone willing to look past the clean version. The first honest glimpse of ThreeI Atlast did not arrive from a space agency. It came from small observatories from backyards and hilltops where people pointed their own telescopes toward Atlast. In those raw frames, Atlast never quite held still, the glow around the nucleus wobbling between exposures. Some nights the coma of Atlast stretched slightly to one side, on other nights the brightness tightened and dimmed. To experienced observers, that restless surface made Atlast feel less like a frozen relic and more like a visitor still adjusting to local conditions. Even when the cameras and settings stayed the same, Atlast shifted just enough to suggest an internal rhythm. That pattern stands out because ordinary comets tend to blur in predictable ways, smearing along their orbits. By contrast, the light of Atlast seemed to hesitate, to lean, to pulse from frame to frame. The more those amateur stacks accumulated, the more a kind of personality emerged around ThreeI, Atlast subtle but unmistakable. Between the pixels, observers began to sense a question forming whether Atlast was simply being pushed by the sun or responding to it. That quiet doubt is what carries us toward the next step, where we follow Atlast into the realm of processed, polished images. Inside, NASA's pipelines, an unruly sky is gently trained to behave. Raw frames of ThreeI Atlast enter that system, looking noisy off-center and uneven from one exposure to the next. Step by step, the engineers subtract bias and dark current, align the stars, stack multiple frames, and sharpen the faint core of Atlast. Every algorithm has a purpose, smoothing stray speckles, cancelling random shifts, turning the field around Atlast into a quiet, stable backdrop. In the final composite, Atlast appears perfectly centered, the coma rounded and calm, a single bright statement instead of many wavering impressions. The same process that rescues detail also averages away small changes in how Atlast glows, leans, or breathes from one moment to another. For an ordinary comet, that loss may not matter, because behavior follows patterns already written in textbooks. For ThreeI Atlast, whose trajectory and composition already strain those patterns, the missing wiggles might be the most interesting part. Somewhere between the individual frames and the polished portrait, a version of Atlast exists that no one ever truly sees. That invisible version carries a quiet weight, as if a living diary of Atlast has been summarized into a single sanitized sentence. As the official image circulates, the story of Atlast drifts towards stability, and a gentle question arises about what has been cleaned away. From that question, a path opens toward deeper models asking how much of Atlast belongs to nature and how much to human processing. Each step in the processing chain quietly rewrites the way ThreeI Atlast exists in our minds. Noise reduction hides the grain in the sky, but it also smooths the tiny tremors that once traced Atlast from frame to frame. Alignment routines pull the stars into a perfect grid, dragging the wandering glow of Atlast toward a single average position. Stacking and normalization compress bright and dim nights together, so the restless breathing of Atlast becomes one steady, comfortable tone. In the raw sequences, Atlast changed just enough to suggest a shifting environment or a changing face toward the sun. In the finished product, Atlast seems to have chosen one expression, and to hold it indefinitely. For ordinary comets, that loss of variability might feel harmless, a technical compromise in service of clarity. For a visitor already marked as unusual, the erased fluctuations around ThreeI Atlast could have carried clues about jets turning on and off, or subtle reorientation across nights. Instead, the public first meets Atlast as a fixed emblem, an object that appears calmer than the data once implied. Somewhere between those two versions, observers are left to wonder whether processing has simply removed distraction or trimmed away behaviour that mattered. That lingering doubt pushes the story of ThreeI Atlast beyond a single photograph and into a deeper question about which reality we decide to trust next. Side by side, the two faces of ThreeI Atlast do not tell the same story. In the official frame, Atlast looks composed, centered, and almost reassuring, as if chaos had been negotiated into order. In the amateur stacks, Atlast feels unsettled, its glow shifting just enough to suggest a changing mood. One version invites the public to trust Atlast as a stable, well-understood visitor. The other hints that Atlast is still in motion both physically and in meaning. Taken together, they imply that neither portrait alone is complete, and that the truth of ThreeI Atlast may live in the space between them, where unanswered questions begin to form. Between the two kinds of images, a quiet gap opens that numbers alone do not describe. In that gap, ThreeI Atlast is no longer just pixels, but a question about how much reality we are allowed to see. Raw frames show Atlast changing from night to night, while processed frames freeze Atlast into a single approved version. The distance between those stories becomes a small blind spot where unmodeled behaviour could live. Maybe that space only contains noise and Atlast is as ordinary as official reports suggest. Maybe that space holds the first hints that Atlast does not fully fit our categories. As we move forward, the way we treat that missing middle will decide whether ThreeI Atlast teaches us comfort or unease. From here, the investigation follows Atlast into the realm of official confirmation. When NASA finally stepped up to the microphone, the story of ThreeI Atlast briefly seemed to settle. After weeks of silence and rumour, the agency confirmed that Atlast behaves as a comet, following a hyperbolic path that will never loop back. In that announcement, ThreeI Atlast joined a very small family, listed as only the third confirmed interstellar visitor humanity has ever measured in detail. Orbital solutions showed Atlast arriving from far beyond the outer planets, swinging once through the inner system, then fading into the dark again. Spectroscopic readings placed ThreeI Atlast comfortably inside the broad envelope of known icy bodies, strange in origin, but familiar in basic behaviour. The language of the brief-framed Atlast as a natural fragment shaped by another star long ago, and now passing through by chance. For many listeners, that description dissolved the sharpest fears wrapping ThreeI Atlast, in the reassuring category of comet a word already mapped in the mind. Yet even in that calm tone, small caveats remained hints that Atlast still carried details not fully pinned down. Those lingering edges quietly pointed forward toward the growing web of spacecraft now watching ThreeI Atlast from multiple vantage points across the solar system. Once the label comet was attached, the quiet pursuit of ThreeI Atlast by the fleet began in earnest. From Mars, orbit cameras on MRO and MAVEN watched Atlast as a faint shifting form against the sky. Closer to the sun, solar sentinels like stereo traced how the brightness of ThreeI Atlast rose and fell with distance and activity. Farther out missions on their way to other targets such as Lucy and Psyche added stray but valuable snapshots of Atlast from unusual angles. Together, these viewpoints wove a continuous timeline, turning ThreeI Atlast from a single press image into thousands of data points across wavelengths. For most comets, no such multi-mission choreography exists, making Atlast one of the best documented interstellar visitors in history. That depth of coverage suggests that ThreeI Atlast should feel fully explained, yet small inconsistencies in light curves and structure still creep through the records. Some instruments see Atlast brightening or reshaping a little faster than standard models predict, while others catch moments that seem oddly quiet. Those mismatches are small, but they keep scientists from closing the book on ThreeI Atlast with absolute confidence. Instead, the shared data set becomes a testing ground, where natural explanations and technological hypotheses must both confront the same stream of numbers. From here, attention turns to what that stream actually says about how familiar or unfamiliar Atlas truly behaves. For many researchers, the strangest thing about ThreeI Atlast is how ordinary it often appears. As Atlas sheds gas and dust near the Sun, its brightness roughly tracks what standard thermal models predict for a comet under increasing heat. The coma of ThreeI Atlast grows and fans out in ways that mostly resemble long-period visitors from the distant Oort cloud. On good nights, the tail of Atlas stretches along its orbit in a familiar arc, as if following rules we already understand. This familiarity is precisely what makes ThreeI Atlast scientifically precious. If Atlast formed around another star, then each molecule leaving its surface carries a chemical accent from a different planetary nursery. By comparing that accent to known comets, scientists can test whether the recipes for icy bodies near other suns match what shaped our own. In that sense, ThreeI Atlast becomes a moving laboratory, a brief unrepeatable experiment drifting through the inner system. Yet even inside that comfort zone, Atlast refuses to be completely average. Small deviations in production rates, tiny shifts in how quickly the coma of ThreeI Atlast thickens, or thins hint that its past was harsher. Cosmic rays in interstellar space may have altered the outer layers of Atlast for billions of years before this encounter. Those scars written into the chemistry of ThreeI Atlast are what turn a normal behavior curve into a time capsule from another epoch. From this realization, attention naturally slides toward what the composition and radiation history of Atlast might be trying to tell us next. Early spectra hinted that ThreeI Atlast was carrying an unusual balance of gases. The ratio of carbon dioxide to water streaming from Atlas sat higher than in many well-studied comets from our own system. On paper, that composition does not break physics, but it nudges ThreeI Atlast away from the comfort of familiar chemical families. To explain the numbers, scientists sketched two main possibilities, each turning Atlast into a different kind of messenger. In the first picture, ThreeI Atlast preserves its original recipe frozen, since formation around a star older than the Sun. If that is true, then every molecule escaping Atlast tonight was mixed in a disk that vanished billions of years ago. In the second picture, the outer layers of ThreeI Atlast have been slowly rewritten by interstellar radiation stripped of water and hardened over eons. Under that scenario, what Atlast shows us now is less a pristine core and more a weathered shell recording the violence of space between stars. Either way, the chemistry of ThreeI Atlast refuses to be just a random detail in a data table. It becomes a quiet clue about where Atlast was born and about what has been done to its surface on the long road to our sky. From here, the argument over how ordinary or artificial Atlast might be cannot ignore the chemical fingerprints it leaves behind. As online theories multiplied, NASA addressed the idea of an artificial origin for ThreeI Atlast directly. Engineers walked through the images showing how odd shapes and sharp glints around Atlast could arise from viewing geometry, exposure time, and overstretched contrast. High-resolution frames revealed a fractured irregular nucleus and a diffuse coma features that matched rugged ice far better than metal plating on ThreeI Atlast. To the agency, nothing in the data demanded thrusters and tenors or engineered panels, only a difficult but natural comet. Still, the need to issue that clarification at all left a faint echo, a reminder that Atlas did not arrive in a neutral climate of trust. Seen from a distance, ThreeI Atlast is less a rock and more a moving archive. The speed of Atlast and the depth of interstellar space it has crossed suggest a journey measured in billions of years. In that span, ThreeI Atlast may have carried untouched ices from a disk that vanished before our own planets finished forming. To sample the gases and dust around Atlast is to dip into conditions that no telescope can rewind directly. In this sense, ThreeI Atlast behaves like a time capsule, preserving both its birth environment and the scars of its passage. The brief window while Atlas passes the Sun is a once-only reading of that record. From this vantage point, ThreeI Atlast becomes a messenger from another epoch, nudging us to ask whether we are listening carefully enough before it is gone. Before asking what ThreeI Atlast is, scientists first ask what any probe must be to cross the stars. Across interstellar distances, the delay between a command and a response grows longer than a human lifetime, so Atlast could never rely on real-time guidance from Earth. A craft moving as far and as fast as ThreeI Atlast would have to make its own course, corrections, its own safety decisions long after its makers are gone. In that picture, Atlast looks less like a remote-controlled machine and more like a ship with its own internal judgment. Engineers imagining such journeys conclude that only something like artificial intelligence can shoulder that burden. To function for tens of thousands of years, a probe like ThreeI Atlast would need to learn from new environments, recognize hazards and adapt without waiting for instructions. Every dust cloud, every gravitational slingshot, every close pass to a star would ask Atlast to choose between countless paths in real time. Even a tiny delay caused by consulting a distant homeworld could mean the difference between survival and destruction for ThreeI Atlast. Seen from this angle, autonomy is not an optional upgrade, but the basic requirement for a traveller like Atlast. That requirement quietly changes how we read the behaviour of ThreeI Atlast when we see precise manoeuvres and finely tuned approaches. Instead of asking only whether Atlast looks like a comet, the question becomes whether Atlast behaves like something thinking its way through space. From there, attention naturally turns to the specific motions and jets of ThreeI Atlast, searching for patterns that resemble decisions rather than accidents. From certain angles, the path of ThreeI Atlast looks less like a fall and more like a choice. Standard models say a comet such as Atlast should drift along a trajectory fixed by gravity and uneven outgassing. Yet when astronomers fit the data, the orbit of ThreeI Atlast tracks a curve that seems almost over-precise. Small deviations line up in ways that make Atlast appear to be nudging itself, not merely being pushed by sunlight. In images taken over time, the brightest jet from ThreeI Atlast often holds nearly the same direction in space. As Atlast rotates, that stability should wobble, producing a fan that sweeps across the stars in a predictable pattern. Instead, observers see a beam from Atlast that stays remarkably steady across long stretches of its path. To keep that alignment by accident would require a very specific combination of spin shape and vent geometry inside ThreeI Atlast. One reading treats these details as a lucky arrangement of fractures and ice pockets on Atlast. Another reading treats them as the signature of active control, as if ThreeI Atlast was steering a low-thrust engine. In that view, every slight correction becomes a decision, and every persistent jet becomes a deliberate push. For people watching from Earth, this possibility wraps ThreeI Atlast in a different kind of unease and wonder. If Atlast is adjusting its own journey, then the sky above is no longer just a stage for passive debris. That realization naturally guides the investigation toward what ThreeI Atlast is made of, and how any hidden propulsion might be powered. When scientists examined what ThreeI Atlast is made of, the numbers refused to sit quietly on the page. Instead of the usual balance of ices, the plume around Atlast showed an unusually strong presence of heavier elements. Signals consistent with nickel appeared more prominent than expected, while the water fraction from ThreeI Atlast hovered at a surprisingly low level. For an ordinary comet, water carries much of the mass that sunlight can push. In the case of ThreeI Atlast, that missing water forces models to work harder to explain how strongly Atlast responds to radiation. When teams fit the trajectory 3, Atlast seems to experience a non-gravitational push large enough to imply that a significant portion of its mass is being shed. Yet no dramatic fragmentation trail trails behind Atlast, no obvious clouds of broken debris to match the inferred loss. One school of thought treats the composition of ThreeI Atlast as a relic of an exotic birth environment where metals and volatile ices mixed in unfamiliar ratios. Another school wonders whether those same metals could form part of a structure, a skin or framework guiding how Atlast vents material. In that picture, the acceleration of ThreeI Atlast begins to look less like random gas escape and more like thrust shaped by design. The line between natural and engineered behaviour blurs, and ThreeI Atlast quietly invites us to decide which side of that line we believe it occupies as we follow its path further. In some of the sharpest frames, a curious glow appears not behind but ahead of ThreeI Atlast. Instead of trailing safely away from the direction of motion, the brightest extension of Atlast leans into the path it is taking. For a natural comet, gas and dust from the surface should stream away from the sun, and the geometry around Atlast should follow that rule most of the time. Here the light around ThreeI Atlast seems to mark a region in front, like a subtle headlamp cutting through darkness. One interpretation says this is just an awkward projection, a trick of angle and timing around Atlast. Another imagines ThreeI Atlast flooding the space ahead with particles or charged light clearing a corridor before its own body arrives. Micrometeoroids at the speeds of Atlast can be deadly, and even grains of dust can strike like tiny bullets. A protective beam from ThreeI Atlast could ionize or nudge those grains aside, turning chaos into a safer channel. If such a system exists, it would explain why the brightest feature around Atlast sometimes points where theory expects the least activity. The idea bends three. Atlast away from the image of a passive rock, and toward the outline of a cautious traveller. For observers, that thought adds a new layer of tension, because a shield implies that Atlast anticipates dangers before they happen. Whether this glow is a simple jet or a deliberate barrier, the pattern invites us to watch how ThreeI Atlast treats the space in front of it as the journey continues. Long before anyone heard of ThreeI Atlast, a narrow radio burst briefly lit up a receiver in 1977. The WOW signal, as it came to be called, seemed to arrive from near Sagittarius, then vanished before it could be confirmed. Decades later, when astronomers traced back the path of ThreeI Atlast, they found that Atlast approaches from a direction not too far from that old mystery. The track of Atlast does not line up perfectly, missing the WOW direction by several degrees, but the proximity keeps the question alive. One hypothesis imagines an earlier route for ThreeI Atlast, with Atlast adjusting course only after sending or receiving a test transmission. To beam a signal strong enough to reach Earth from several light days away, Atlast would have needed an energy output on the scale of large power plants. Under that scenario, the WOW burst becomes less a random flare and more a handshake between Atlast and its origin, a ping that Atlast answered with a change in flight path. Skeptics point out that space is full of coincidences, and that ThreeI Atlast can be explained without tying it to a single blip in old data. Even so, the geometric near miss between the WOW region and the arrival direction of Atlast lingers in the background. For those willing to entertain the idea of an artificial traveller, ThreeI Atlast turns the 1977 signal from an isolated curiosity into a possible prologue. From here, attention shifts to how often Atlast might repeat such communication, and whether new instruments can catch ThreeI Atlast speaking again as it passes through our neighbourhood. Some critics argue that the biggest obstacle to understanding ThreeI Atlast is not data, but assumptions. When scientists approach Atlast already convinced that ThreeI Atlast is only a rock, they design observations to confirm that comfort. Telescopes look for familiar gases for simple dust behaviour for tails and comet that match charts drawn long ago for objects unlike Atlast. In that mindset, nobody asks whether ThreeI Atlast might leak waste heat from computation or brief surges from controlled thrust. No one schedules deep searches for narrowband emissions that might flicker from Atlast at odd machine-like intervals. Time on powerful instruments is precious, and proposals that treat ThreeI Atlast as potential technology often die before pointing ever begins. The criticism is not that scientists are dishonest, but that human caution quietly fences ThreeI Atlast inside a safe category. As long as Atlast wears the word comet-like armour, the most sensitive tools rarely look for anything more. Under that armour, subtle signatures that would support a technological hypothesis for ThreeI Atlast may pass unnoticed, folded into background noise. For those who see ThreeI Atlast as an opportunity, this is the real risk, not invasion or collision. The danger is that Atlast could whisper in the one way we never thought to listen. From this worry comes a gentle push to reframe observation plans to treat ThreeI Atlast as both rock and possible signal as the story continues. If ThreeI Atlast is more than a single body, then the real story may unfold in what separates from it. In some models, a long-range probe like Atlast is only the carrier designed to shed smaller instruments when it reaches a system worth studying. Those scenarios picture ThreeI Atlast dropping tiny daughter craft into stable orbits around planets, moons, or even along magnetic field lines. Once released, those fragments would be faint, slow, and easy to overlook against the clutter near Earth or Jupiter. For observers, this raises a quiet challenge. If ThreeI Atlast is acting as a parent, then a complete investigation cannot end with tracking only the main nucleus of Atlast. Surveys would need to comb the regions Atlast passes, looking for new unexplained objects that appear along its trail. Any cluster of small bodies sharing an unusual path with ThreeI Atlast could mark the footprint of deployment rather than chance. So far, no confirmed swarm has been tied to Atlast, and the sky remains officially empty of such children. but every time 3I Atlast passes close to a planet or through a region of gravitational balance, the possibility returns. In the quiet hours, it is easy to imagine Atlast seeding silent watchers behind it, leaving us to decide whether we noticed in time. That thought bends the narrative from a single visiting comet toward a dispersed presence with 3I Atlast as only the first hint. The latest wave of measurements arrived quietly, but they changed the way 3I Atlast had to be described. New images of Atlast came in sharper, deeper, and from angles no one had expected to obtain so soon. Brightness profiles around 3I Atlast, tiny shifts in structure, and refined orbital numbers all lined up with a strange precision. On paper, the new figures pushed Atlast further away from ordinary comets, yet the public story bent in the opposite direction. During the official briefing, 3I Atlast was framed as nothing extraordinary, a natural visitor that just happened to come from between the stars. The presentation moved quickly past the more unsettling coincidences, smoothing the behaviour of Atlast into familiar language about dust and ice. Mentions of unusual ratios, forward-leaning light and finely tuned approaches by 3I Atlast were wrapped in careful qualifiers and moved aside. Outside that room, some scientists quietly noted that the same data could have supported far more provocative questions about Atlast. Instead, the narrative settled into reassurance, as if the main task was to calm audiences rather than follow every odd thread from 3I Atlast. This tension between what the numbers suggest and what the summary emphasizes becomes its own kind of anomaly. From here, the investigation begins to focus on specific geometric puzzles around 3I Atlast, places where coincidence and intention start to look uncomfortably close. The first high-resolution frame that showed a glow stretching in front of 3I Atlast felt quietly wrong. Instead of a tail streaming away from the sun, the brightest structure around Atlast leaned into the direction of travel like a spear. Standard comet physics says gas and dust should roughly follow the solar push, so features ought to trail behind the nucleus of 3I Atlast. Here the main plume ignored that expectation, marking a patch of space ahead of Atlast, rather than the wake behind. Teams checked viewing geometry, phase angles and exposure tricks, trying to fold the misaligned light of 3I Atlast back into projection errors. After those corrections, the forward glow persisted, still anchored to the path in front of Atlast, instead of relaxing into a normal tail. One cautious explanation keeps the anomaly natural, imagining a vent on 3I Atlast positioned just right to mimic a forward beam. A bolder explanation treats the glow as an active shield with Atlast spraying particles, or charged light ahead to clear micrometeoroids from the path. For anyone watching, 3I Atlast, that second picture is hard to forget, and it nudges attention toward how precisely the trajectory of Atlast brushes the reach of giants like Jupiter next. When orbital dynamicists ran the numbers, one detail about 3I Atlast refused to fade into the background. The calculated hill radius of Jupiter, the rough edge of the giant's gravitational domain, fell at a distance almost identical to Atlast's predicted closest approach. On the day of that pass, the boundary for capture and the minimum distance of 3, Atlast differed by only a tiny fraction. For a hyperbolic visitor wandering through billions of possible paths that near match gives Atlast the feel of aiming for a doorframe not drifting. Statistically random trajectories should miss such a boundary, by far more generous margins, making the alignment around 3I Atlast an uncomfortable outlier. Some analysts assign odds of roughly 1 in tens of thousands that a purely natural comet would just graze Jupiter's hill radius so cleanly. In the conservative view, 3I Atlast simply threaded a rare needle by chance, an elegant accident with no deeper meaning. In the more provocative view, the non-gravitational acceleration already measured for Atlast becomes the gentle push that steered this precise encounter. Under that interpretation, 3I Atlast is not merely passing Jupiter, Atlast is tapping the edge of a vast well on purpose. The hill radius then looks less like a coincidence and more like a staging ring, a place where Atlast could leave something behind. From here, questions naturally turn to what 3I Atlast might do with such a position, and whether Jupiter's neighbourhood will show new arrivals after the flyby. If the closest approach to Jupiter is not an accident, then 3I Atlast begins to look like a courier choosing a very specific drop-off zone. From the edge of that giant's hill radius, Atlast would need only modest impulses to leave small payloads in long-lived orbits. Engineers imagine 3I Atlast releasing probes toward regions like the L1 and L2 points, where gravity and motion balance into quiet harbours. Once settled there, those devices could watch Jupiter and the inner system for years, long after Atlast has moved on. In this scenario, the measured non-gravitational acceleration of ThreeI Atlast is not a quirk of sublimating ice. The same gentle push that alters the path of Atlast could be the guidance system for a delivery maneuver. From far away, no observer would see the devices themselves, only the slightly adjusted curve that ThreeI Atlast traces past Jupiter. The geometry would look almost the same as a natural flyby, with a purpose hidden just beneath the threshold of certainty. For those following ThreeI Atlast, this possibility changes the emotional weight of every update. The question is no longer only where Atlast will go, but what Atlast might quietly leave behind near the largest planet before the journey continues inward. In the simplest classroom diagrams, a comet drifts along a smooth arc, but the measured path of ThreeI Atlast keeps stepping sideways. At certain points, Atlast shows abrupt shifts in trajectory that line up too cleanly with bursts of non-gravitational acceleration. Models that treat ThreeI Atlast as an ordinary fragment also struggle with density because the inferred mass and size do not comfortably agree. From some viewing angles, dust around Atlast forms an anti-tail pointing sunward, the reverse of what standard behaviour suggests. On top of that, the route of ThreeI Atlast brushes unusually close to Mars, Venus and Jupiter, as if the travel corridor of Atlast had been favoured by an unlikely alignment. Taken together, these motion and origin clues pull ThreeI Atlast away from the picture of a simple wanderer and nudge the narrative toward deeper questions that the next entries in the catalogue must confront. The chemistry of ThreeI Atlast refuses to fit quiet tables. Spectra around Atlast show metallic lines with nickel enhanced beyond standard comet expectations. At the same time, gas from ThreeI Atlast carries a small share of water straining sublimation models. Polarization linked to Atlast dives into negative values rarely seen in other icy bodies. To match the brightness and non-gravitational acceleration of ThreeI Atlast models demand mass loss with no clear trail of debris. Some call these signs of harsh birth and long interstellar weathering on Atlast. Others let ThreeI Atlast wear them as hints of engineered skins and tuned exhaust, nudging the story toward design rather than accident. For an object as unusual as ThreeI Atlast, opportunistic snapshots are no longer enough. Without a coordinated campaign, every telescope catches Atlast on a different night with different filters and shallow exposure. The result is a patchwork where ThreeI Atlast looks slightly different in every frame, and patterns dissolve in the gaps. In that missing continuity, a forward glow around Atlast can be dismissed as noise instead of tested as a shield. The beam hypothesis imagines ThreeI Atlast constantly sweeping particles, or charged light ahead carving a safer path. To confirm or reject that idea, observers must watch Atlast without long pauses across wavelengths and rotations. Only then can ThreeI Atlast show whether the light in front is a simple jet or the signature of an active defense guiding the next phase of the story. A leaked analysis suggested that ThreeI Atlast was no longer following a simple fall. Orbital plots showed ThreeI Atlast executing 3 small but sharply defined adjustments over recent cycles. Each tweak nudged the path of Atlast closer to a narrow region known as a near-collision corridor, the strip of space where close approaches to Earth become possible. In forward projections, that corridor intersected the future track of ThreeI Atlast roughly 60 to 90 days ahead. To some, the alignment was a statistical fluke, a coincidence on paper. To others, the regularity of the shifts made ThreeI Atlast feel as if a schedule were being kept. The corridor in those models did not guarantee impact, but it framed Atlast as an object choosing where to pass rather than merely where to fall. The first sign that something stranger was unfolding around ThreeI Atlast did not come from light. It came from a series of faint radio pulses that appeared while telescopes traced the new course of Atlast. Over 3 separate observing sessions, instruments recorded a narrow burst repeating every 19 hours, almost to the minute each time Atlast turned up in the beam. Engineers suspected a fault and checked receivers' clocks and software before they dared leave the signal attached to ThreeI Atlast. When the equipment cleared, analysts overlaid the timing of the pulses on the evolving orbit of Atlast. The pattern settled into a disturbing symmetry because each cluster of 19-hour pulses lined up with the intervals when ThreeI Atlast made its small orbital adjustments. The data did not print the words directly, but on the trajectory plots, Atlast looked as if it listened, then moved. Natural objects do not typically wait for a repeating schedule before changing their paths, yet the rhythm around ThreeI Atlast felt alarmingly precise. Conservative voices argued that both the radio and the shifts could still be unconnected coincidences near Atlast. Others read the 19-hour cycle as a kind of heartbeat, the tick of an internal system inside ThreeI Atlast, responding to some unseen command. If that view is correct, then each maneuver turns 3I Atlast into something more like a vessel following instructions than a comet shedding gas. For those alone in control rooms at night, the thought settles heavily, because it suggests that 3I Atlast is not just moving through space. It suggests that Atlast might be part of a conversation, one half of an exchange we are only now noticing as its path curves closer to our world. The first radar reconstructions of 3I Atlast suggested that something about the surface was quietly wrong for a simple chunk of ice. Instead of scattering the signal in a soft powdery pattern, Atlast reflected energy like a crystalline metal with sharp, bright returns from narrow regions. As the models improved, the best fit for 3I Atlast was not a rounded boulder, but a body marked by planes edges and long straight grooves. In close analysis, the echoes from 3I Atlast behaved as if they were bouncing off repeating structures, not random fractures. The way those reflections changed with angle hinted at a lattice, a pattern more at home in engineered alloys than in frozen rubble. Spectral readings around Atlast reinforced the impression, showing signatures that lined up with dense, ordered material where porous ice would normally dominate. One camp argued that 3I Atlast might simply be the survivor of a violent past shattered and refrozen into an unusually rigid shell. Another camp looked at the regularity and saw the ghost of design as if Atlast were the corroded chassis of a long silent machine. In that view, the grooves on 3I Atlast become channels and seams, not cracks, and the reflective surfaces become panels instead of chance facets. For those contemplating this possibility, 3I Atlast starts to feel less like an untouched relic, and more like discarded hardware still following a script. That shift in perspective carries forward into the next questions, where the behaviour of Atlast is read not just as motion, but as the awakening of a device that remembers what it was built to do. Behind official summaries, smaller rooms began to hold a different conversation about 3I Atlast. In those internal meetings, analysts treated Atlast less as debris, and more as a system moving through phases. The 19-hour pulses, the timed orbital nudges, and the metallic reflections were rearranged into a single hypothesis that 3I Atlast was slowly waking up a survey program. In that frame, the maneuvers of Atlast marked checkpoints, each adjustment aligning 3I Atlast with new lines of sight and targets. What looked like simple course corrections became stages in a mission plan spaced out over years of travel. Some models even mapped possible sensor activation windows, predicting when 3I Atlast would switch from passive flight to focused observation. For those reading the classified charts, 3I Atlast no longer felt like an accident near Earth. Atlast felt like a device stepping through a checklist, approaching the point where the next task in its long programmed sequence would quietly begin. When simulators advanced the timeline, the future path of 3I Atlast began to curve in unsettling ways. Instead of coasting smoothly along a gravity-set arc, Atlast appeared to make incremental course changes that always bent back toward the same narrow corridor near Earth. When frictionless models were removed, 3I Atlast still showed a pattern of subtle deceleration, as if Atlast were easing down before entering a critical zone. Natural forces rarely conspire to slow an object so gently and consistently at just the right segment of its journey. On the screens, the orbit of 3I Atlast started to look less like a fall and more like a docking approach. Analysts watching Atlast realized that each new dataset reinforced the same impression. 3I Atlast seemed to be choosing how fast to arrive, as though something about the upcoming region required a deliberate, careful entry. In any serious investigation, the timeline is the spine, and with 3I Atlast, that spine keeps disappearing. Early detection reports of Atlast were quietly revised, with original raw entries replaced by cleaner summaries. Photometric logs that once noted odd reflections from 3I Atlast were removed from public archives without comment. Later radio observatories that had recorded faint pulses near the track of Atlast found those sessions sealed behind new access rules. Requests for clarification returned only vague references to data quality and storage limits, never naming 3I Atlast directly. Seen one by one, each gap could be dismissed as ordinary housekeeping. Seen together, the missing pieces form a pattern around Atlast, as if someone were trimming the story to fit a safer script. Analysts piecing back fragments of the 3I Atlast record find themselves reading not just what was measured, but what was quietly arranged, never to be seen in full. The official memos speak carefully about collision risk, and they keep repeating the same phrase about 3I Atlast. The phrase is not a threat to impact, as if the main comfort they can offer about Atlast is that the ground will not shake. For those reading deeper, that reassurance barely touches the real concern because the fear around ThreeI Atlast does not live in the moment of impact. The fear lives in the way Atlast seems to be arranging for a perfect view. Models show ThreeI Atlast bending into a corridor that offers long, clear lines of sight across the Earth-Moon system. In some trajectories, Atlas passes slowly enough, and at just the right angle for sustained observation of our night side and day side our radio glow and thermal skin. From that vantage, ThreeI Atlast could map fields, traffic emissions and hidden heat, building a portrait of our world with a patience no satellite of ours can match. In the more speculative charts, ThreeI Atlast does more than watch. Those scenarios picture Atlast releasing smaller devices during the close-pass seeds that drift into orbits where no one expects to find them. By the time the main body of ThreeI Atlast is gone, the instruments would remain tiny and quiet listening. For people lying awake under the same sky, the question then shifts. The question is no longer will ThreeI Atlast hit us, but how long has Atlast already been watching, and what happens when the watching is complete?